Hello and welcome back. Welcome to the second section in this course. In this section, we will going to take 1. What is machine learning? 2. Model representation, cost function, and the types of cost functions, gradient descent and its types. 3. Problem statement and solution. What is machine learning? In this video, we are going to take 1. What is machine learning? 2. Machine learning categories. 3. The algorithms that used in machine learning. Machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. And more engineering-oriented one, a computer program is said to learn from experience E with respect to some task T and some performance measure B, if its performance on T, as measured by B, improves with experience E. Suppose you want to build a system that can distinguish that if this picture is dog or not. Examples that the system uses to learn are called the training set. The images here is called X, and the answer is called Y. Examples here is representing the dog's images. These examples is called training set. Each training example is called training sample. In this case, the task T is to classify the dogs for the new images that should be given to the system. Here, the experience E is the training data, and the performance measure B needs to be defined. For example, you can use the ratio of correctly classified dogs. This particular performance measure is called accuracy, and it's often used in classification tasks. I wanted to mention that the input data is not just only images. It can be voices, for example, recognizing humans and distinguish between them. Also, it can be a database, like our example in this section, expanding a food truck business, and the other example in the next section of predicting the housing prices. Machine learning systems can be classified according to the type of supervision they get during training. There are 4 major categories. 1. Supervised learning. 2. Unsupervised learning. 3. Semi-supervised learning. And 4. Reinforcement learning. We will cover in this course the first 2 categories, and the other 2 will be discussed later in another course. The first category is supervised learning. In any supervised learning system, you can find 2 main items. The first one, the algorithm that runs this system. For example, 1. Linear regression. 2. Logistic regression. 3. Support vector machine. 4. Decision trees and random forest. 5. Key nearest neighbors. And 6. Neural networks. The second item is the dataset, and the examples are labeled data. The second category is unsupervised learning. In unsupervised learning, as you might guess, unlike the supervised learning, the training set data has the input X and the true output Y. That's called labeled data. But the unsupervised learning, the training data is unlabeled. The system tries to learn without a teacher. For example, say you have a lot of data contains an images for different types of fruits. For example, orange, apple, and banana. Here is the system. Here is the input raw data. There is no answer describes each image. But here, the task is trying to cluster those fruits into 3 categories, depends on the type. We can build this system using different type of clustering algorithms, like for example, k-means clustering, hierarchical clustering analysis, expectation maximization, and for visualization and dimensionality reduction that used to help clustering algorithms runs faster, principal component analysis, kernel principal component analysis, locally linear embedding, T-distributed stochastic neighbor embedding. Yet another important unsupervised task is anomaly detection. For example, detecting unusual credit card transactions to prevent fraud, catching manufacturing defects. Also, detecting anomalies in server computers that we will learn about it in section 5. The system is trained with normal instances, and when it sees a new instance, it can tell whether it look like normal or whether it look like anomaly. And that's it.